focus will be, this was the first slide, to understand $15.7 trillion economical impact of Gen AI, what we call LLM models, and the AI in general. And what does it mean for all of us? 65% of the skill shift will happen because of this. So that's what we are going to look at it. Refocus yourself, whatever you do, 65% skills are shifted. We'll talk more. This I was talking about my company, TDM. We ourselves took an initiative to reshift our focus from what we are doing to where we should focus for 2030. And the shift is we are ignoring quantum right now. We are ignoring DiFi right now, which is upcoming technology. And as this grows, by 2030, quantum will be the real thing. All this AI has been generated. It does not have computational power to hold it. 256 SHA bytecode is not enough to run a self-driving car. We all know about it. It can do a little bit of it, but when you go further, you have to use advanced technology. So that's our refocus. Full of our credentials, as I was talking before, we have worked with the US Navy, Niagara Bottling, couple of good companies, General Electric. As a company, as product offering, we have done that. From education point of view, we are top 10 rated in multiple rating systems, CIO magazine, bootcamp if you are a learner. This is my background. I've been doing this for 20 years almost, but everyone needs some kind of an upgrade. When I started 2000, it was doing fuzzy logic and decision tree and making robotic control arms, those kind of things. Now with data, things have changed. So I went to System Labs, MIT to upgrade myself. And then I have a background in business side from MIT Sloan Business. Let's look at this in deeper. What does $15.7 trillion change means? This is from McKinsey, it's not from us. They said the breakdown of $15.7 trillion, we came up with an average of 14,000 impact on every person. That means if you are already in a good job, you possibly can get a 14,000 increment, just making it fun a little bit. They also came up 63 use cases. I think it may be more. I don't have the list for it. These are the industry where major impacts. They are saying $1.2 trillion into software engineering and sales and marketing. So it's a good news. Average person can move towards this side. Customer operations, research and development, other functions like retail, all those things are impacted. 70% people who are workforce is already impacted. We said 65%. McKinsey is now at 70%. 50% of activities are automated. So that's another thing we have to keep in mind. This is a journey of evaluation of large language models. They are nothing new for people who have been trying to do. My first encounter of LSTM and RNN models were in 2017 and 18, not to a level where they are. And it has evolved to where it is right now. These are some models which are really popular right now, and every second or third day or second or third month, you see something new is coming up. I'll tell you why. Tuning of large language models have become common. You can do this kind of algorithms on your own data set, that I'll talk about it a little bit further in the slides. And you will take a big corpus of large language model, something like ChatGPT, and you can use it for your own experiment. So that's the focus, to see how things have shifted. I was talking about major contribution happening to the industry. 4 of them, healthcare, finance, and real estate, and education. Fortunately, we have worked in 3 in a very leading way. Healthcare, we did some drug addiction therapy bot in 2019. It's also our app. It's on the App Store. Then we did some real estate, has been big portfolio for us. We built something called ZDI or Z1 data in Asia, Singapore, Thailand, Cambodia, where we were able to replicate a predictive modeling for land, commercial, and residential. And in EdTech, we have our own platform which recognizes your facial expressions, and if you are falling asleep on camera while studying, we know, and also authenticate who is taking the exam. So those 2 problems we solve. This is for the beginners or someone at intermediate stage of their career. 25% new opportunities are created, 20% is transformed, which is very, very important to understand. And if you are, whatever you are doing, you have to move towards educating yourself in AI side. Major companies who are doing this is Google, Amazon, Microsoft, Meta platform, Tesla, we all know about it. So these are major players. It takes billions and billions of dollars to come up with this kind of AI. This is where most of you, which I see in other gatherings and webinar, falls into. I call awareness or knowledge building. All of us either go to YouTube or learn through Coursera or other places, which is good. Skill building is different. So all of you, whoever you are, possibly will get impacted with this change. These are all machine learning, programming, natural language processing. So everything has changed to a level. My goal will be to show you how to connect these pieces together today and how to utilize this new upcoming technology. Okay, so next thing which I'm going to do is just run a process of machine learning model. The goal is not to go how to fine-tune a model or how to classify a model, though I'm going to talk for beginner level. What does it mean? But the goal is to look at this in a whole big perspective to understand the big blueprint and how do you drill down for yourself and how we can contribute to you. That's my goal today. So we took a medical use case where you can say cancer, not cancer, diabetes, not diabetes, standard. And we dig through the data. So I'm going to walk you through step-by-step process for very, very beginner, people who have awareness or done some searching around what data science and AI machine learning projects are. And I'm going to give you step-by-step how they're executed. And then from there, we'll go to how to connect large language models with it and what's the landscape change. So this is how you do your machine learning, data science project. Step number one, you'll try to understand let me see, I have some messages. So step number one in doing machine learning prediction is understanding the business problem. Every data science and AI problem is posed as something written statement. You will, as a scientist, have to drill down. Your job starts from a data acquisition stage. Maybe data engineer does it, but if you are new, you have to understand this part, data acquisition. And from there, you will understand the patterns in the data, which I'm going to talk about, and analyze the data to select the model, and then build the model. And the last phase of this experiment will be to evaluate a model by scoring and performance monitoring. So these are basic 101 for doing a data science experiment. So I've broken down this into steps. So step number one will be acquiring data and exploring it. And this is how it works. You collect the data, clean the data, do some feature engineering. Then you go to the modeling and deploy the model and monitor the monitor. These are some basic steps. So I brought in a data set with some medical data records. And this is understanding through pandas. So you just do an info. This is a detailed understanding of that data. As I said, I'm not going to go detail micro level. So this data set has about 8 columns. All of them are filled. If you're new to data.disk will give you the distribution around this data set. So it gives you a count 768. All the rows and columns are filled. Almost mean, medium, standard deviation on the distribution of the data set itself. Now, once we have this data digged in, what we'll do is we'll try to process the data and understand what are the correlationship between this data set, which is done through exploratory data analysis, EDA. There are a couple of libraries, matplotlib, Seaborn, there are D3JS, other visual libraries. So data collection is done, processing, formatting, cleaning, scaling and monitoring, decomposition and aggregation. These are the steps when you play with the data collection and formatting, clean it, drop some things, replace something. And you have to scale it or normalize the data to be ready for the visualization as well as for the modeling. So this is the next step. In my data set, sorry, this is sensitive. I have the data set already has the person has a disease or not disease qualified, and then I have the whole data set. So that's how I looked at into two target variables versus what I have. And then what I did is I did a pair plot here to understand all this prediction existing and what are the three labels out of it. 2 labels, sorry. You can explore this more by yourself. This is called a heat map, where we can take questions towards the end on this topic too, where you can find a relationship between your columns and rows and draw a map. So if you say blood pressure related with blood pressure is 100%, but if it is insulin related with pregnancy is 0.13. So this heat maps give you the correlationship between two columns. It's very beautiful to understand this in a visual form. You will go to a Seaborn package and get a heat map, put up a correlation, this syntax, and you can look at this one this way. Now, preparation of data is for modeling. This is a little bit important concept. You take your data set for very, very beginner. This is just to give you a full scope. Let's say you have a full data set and you want to build a model to test and train both. So first step will be you train the model to understand what is a machine learning problem you are solving, and how you will train your machine learning on a training set and then test it on the remaining portion of the data set. So there are a lot of techniques involved into. You can take the whole data set. Sorry, my mouse is sensitive. You can take the whole data set and split it into 70-30, 25-75, 60-40. The bigger question becomes, if I have a small data set, what do I do? So there are K-Forge models and other ways to play with small data set. There are a couple of other techniques. So if you want to know a little bit more, there's more to 70-30 or 60-40. You can go to scikit-learn library and look at how this train and test split work. You can also feed the data and train and test model in a very different state, randomized state, 1, 2, 3, there are numbers, and then shuffle. You can feed the data in some random ways or array ways, or some kind of a algorithmic way to make your training and test more valuable, especially when you have a small experiment and small data. Now, once we have worked with the data, we now ready to shoot for what kind of algorithms we should use. What kind of machine learning problem is this? And how do we know which algorithm to be picked? So from learner's point of view, this is kind of a machine learning roadmap. You can pull this up from scikit-learn library, which is very popular, open source. Or I can send you these slides. If you request for it, just drop me a message. So when you start your experiment, you have to ask a question to yourself, what kind of problem do I have? Now, the first problem we asked was business problem. Now we are to a point where now we have done the analysis, understood the EDA patterns in the data, understood what I'm feeding, and I'm done the split. I have to decide what kind of machine learning algorithm I should use. This is where this roadmap comes in play. So when you start, you ask yourself first question, do I have enough data? And the answer is no, then forget about this experiment. Go and find a way to collect some data or whatever it takes. Second is, if you have the data, what kind of data you have? Is it categorical or quantitative? Quantitative is continuous, like time series or stock market or those kind of things. Continuous feed of the data. Categorical is it red and blue, green, orange? Those kind of things. Red, blue, green, orange, I said color means different variety of data. So if it is labeled categorical, can I label it? Can I say, is it a red and blue? Or I can see red, blue, green, orange, multiple flavors of group data. So if you can label it straightforward, red and blue, it becomes a classification problem. That's your classification side of the data. If you have more flavors, red, blue, green, orange, and you see clusters, bunch of red is one side, bunch of blue is one side, bunch of green is, it's a clustering problem. And then clustering algorithms can be used to evaluate this. Next is, if it is a quantitative, I see numbers happening. Is it a continuous flow of the data? That might be possibly a regression problem. If it is not quantitative and I cannot figure out this too much mixing, okay, now I need to do to separate them, at the same time draw value out of it. Now we have to go through TCA, dimensional reduction problem. So for example, if you Yeah, the emission reduction. You just take 10 features and reduce to 3 or 2 and then see the value. I could have given facial recognition example, but that will take longer time. So I kind of hold it on it. Now, so I'm to a point now. Let me roll back this experiment a little bit. I did 3 steps, understood the business problem, which was Y and X axis. Then I brought some data and did some visualization to understand, okay, what's going on here. And then from there, I did train and test split for my data to be fit in a model. So that's where I am right now. So first 1, 2, 3 steps are done. These are acquisition and exploring data. Step number 1, we went through that process. Step number 2, obviously exploring and understanding the data, which we did. We look at distribution. We did some visuals here. What does the whole data set versus outcome look like? Then from here, I did a pair plot to understand the correlationship between outcome and the whole data set. So I want to know if this person has a disease and the whole data set, how it's performing. So orange and blue, 2 colors. This was a heat map to understand the correlationship between columns and rows, how they are correlated. BMI, for example, is directly connected to pregnancy, or sickness. Insulin is connected to glucose level. Those kind of things you can draw from these numbers. Then I went further and took the data set now, and I said, okay, how do I now get the data set ready for an experiment? There are standard rules, or standard way to do is you split the data set into train and test. We talked here how to split, what ways you can feed the data to machine learning. So that's good. Then now, third step is now we are ready to do a machine learning algorithm call, feed to the machine learning. We went through this process, how to select the machine learning model. Mine is the continuous data, which I have it. I have Y predictor is the disease and X is all the data set having 784 rows. So I'm going to go regression side. It's a continuous problem, but my outcome has to be yes or no. So I'm going to go less or regression, which comes as a binary output, yes or no. Rather than going to the classification side, I could have also pick up a classification model like decision tree or random forest. That's fine too. But I went on this side. That's what I'm going to do. So now Y variable is the outcome and X variable is the feed on the data. I split it, which I said here. The split size is 80-20. Random state is 42, and then I fed the whole data set as an outcome. I built the model, regression, I trained, test, and I'm taking Y as a predictor, X as an input. The goal here in this experiment is to know if a person has a disease or not disease. So kind of, but in reality, there are intermediate stage, false, true, false, true, positive, true, negative. A person may be 75% having a disease, but 25% not. But to call a disease, you have to be very close to 97 or more % accuracy. So there are intermediate state. And how do you measure that? That's the performance of the algorithm. And how do you understand that? So that's what we will try to do. So this technique, last phase of machine learning model, is called evaluation. In my case, I brought something called confusion matrix, which measure, I'll explain a little bit. The intermediate state it is a disease or not a disease, but the intermediate state, we cannot consider it as a disease or not a disease. So evaluation methods, precision, recall, F1, you can explore by yourself, too short to talk on a webinar. But if you need my help or our team help, you are most welcome to reach out to give you more detail on these topics. This diagram I got from Wikipedia, so you can just Google it and get it. So this is how a confusion matrix look like. This is your whole data set, which has positives and negatives. You can actual condition. Positive, it is true. Negative, positive in semi-state. Negative, true, negative does not have a disease. So all this intermediate state are where the problem happens. You want positive. When you say someone has a cancer, he should have a cancer. He has a cancer, not sure. When you say someone does not have a cancer, he does not have a cancer. You cannot go false negative or false positive, but you will see in the data. You will see in the data. So we plot this kind of metrics to be very accurate. There are various techniques, RMSE value, mean squared error, all those things. In this case, this guy has a cancer and this guy does not have a cancer. Total of 12 sample. So we are very clear. But in the experiment, you can see 6, 3, 2, 1. So there are intermediate states. So this is why we need confusion metrics. So I built that through scikit-learn again, put my predictor and got some score, what you saw there. And then I draw a heat map based on that. 84% have that particular problem. This may not, 29 do not have, and these are the gray areas. Hypothetical, this is all hypothetical. So experiment data and webinar data, to be honest. So this was about how do you do a sample machine learning example. Let's look at now the exciting part, which makes me feel that this is where we can really add some good thinking value of this webinar. So most of you are to a point where you have done some kind of a work or you are aware about machine learning. I'm assuming that, which is normal of a persona who comes to this webinar. Either you have awareness or you have a skill or you've gone through some educational, wherever you are, it does not matter. The new opportunity lies here, which we call prompting or large language model integration. So this is your architecture change, not a perfect one, just a diagram. So, you build your model, collected data, went through the model evaluation, validation, which we talk about. Model registry is there. Adoption. You're still doing some process here. You did this standard. This is an external integration. Sorry about my mouse thing. Always messes up. So let's say this experiment is about diabetes, non-diabetes, and we raise a question. We associate diabetes or non-diabetes to an insulin level, which is true, but it's also a lifestyle problem, most of it. That's how I understand it. So we go on x.com or Twitter and create a feed, or we need to mine tutor data. What does people talk about this decision we made through machine learning? That's where you can extend your experiment to be integrated with large language models. So how do we do that? There's a concept called transfer learning. If you guys are not aware about it, I'll just do a small introduction of it. It's called pre-trained models. For example, ChatGPT is a pre-trained model. ChatGPT 3, 4, 5, whatever you want to call it. So how do you narrow down to ChatGPT to ask the right question? Okay, I have my insulin level at between 100 to 120. Am I a pre-diabetic? If I'm a pre-diabetic, what are the past 3 people experience on this stage and how do I take help? For example, this is a transfer learning example where you're going from one problem of machine learning and calling an external trained model to get the feedback, or transfer your learned vector to this model. In a very raw, simple words. Data adoption, fine-tuning and modeling. Obviously, you will take whatever you have, fine-tune it. Safety mitigation, you don't want to possibly pass your phone number, gender type, or some sensitive. Distillation, you'll narrow down to and what you call agent model. In this kind of case, student and teacher model. Your corpus, you're going to design using GAN or something like this. These are the steps how to do it. Tuning, quantization, where it uses a precision LLM model using weights and activation. Knowledge distillation, you will narrow down to what your basic problem is. Some low-ranking factor decomposition, maybe gender is important in this problem, age is important, but maybe location is not important. So that you can narrow down. Compact embedding, these are some basic high-level terms to be further drilled down. And then architecture change, which I showed you in the beginning, where you are able to attach this kind of experiment to your outcome to give a proper validation of your work. Parameter sharing, now you'll transfer this model to something else. Maybe you want to feed to a visual presentation on social media that I've been evaluating 10,000 people in my area, and this is the daily glucose level, and this is what their activities are, and this is past sentiments, and you can predict the new sentiments around that. That can be done by parameter sharing from one to another. The teacher-student process following in LLM. GAN models are decoder, decoder, encoder, decoder, encoder, encoder, and it's like generator and decoder. So in a very, very simplified way I'm talking about. So if you are new to ChatGPT, usually they say, pretend you are a scientist, pretend you are a student, and go to the corpus LLM model and ask this particular question. This is what this model is talking about. Train LLM as the teacher model. That means it has the whole knowledge on large corpus. Generate a synthetic example using teacher model by sampling from the model and distribute by specific prompts. Now, as a student, you prompt it. Train the small LLM student model into a small number of labels along with synthetic examples or teacher models. So we'll look at it more detail. Fine-tune the student model for a small validation and optimize it for the performance. Again, step by step, broke off generative model GAN into generator and decoder. Decoder is a student, generator is a major corpus. To do that, there's a wrapper which is growing very fast. Build smart AI using LangChain. This library, you can Google it. This allows you to access the large language models and fine-tune it specifically for what points we talk here. All this, tuning, quantization, low ranking factor, compacting, is as good as doing a Python program with a little bit more knowledge. So LangChain provides a framework for changing multiple large language models, bringing it together. You can also combine models. All the models are not, large language models are not trained on everything. If you go to Bloomberg model, they are trained on financial records, right? Not sentiments. So maybe they are trained on sentiments, I don't know. But that's how I look at it. So rather than relying on single model, you can combine different models with comprehensive strength. A LangChain handle interaction between models and allow them to build on each other output. Three kind of integrations are very common. LangChain is one platform, but conversational AI, which we look at in ChatGPT format, document summarization, law firms are doing this big time. And anyone who has a lot of PDF to be read, where you can summarize the document, create content out of it, query it, researchers are doing it big time. So going back to my original talk, where I said everyone is impacted, researchers are too. So if you're writing a thesis, now you have a better way to understand what others have done and possibly come up with something very unique. Code generator, amazing. It goes to a point where it can give you debug values and all that thing. We use it all day. And the exciting part is you don't have to, syntax was automated by tap. Now it generates you almost the code and the solution. Very advanced now. So one of the things which I was trying to understand is, as a professional, how does this impact the software industry? It's a huge impact, not only what you can create, but what you can transform. If you guys been long enough, legacy systems, which are IBM mainframes and all those things, they took hundreds of years to, not hundreds, sorry, 20 or 30 years to be built. And it's very hard to transform them to the latest code and the latest. This is one of the biggest opportunity with Gen AI about it. You can take legacy system and transform to the latest code in the fastest way and possibly deploy it, keeping the same logic and flow. So why LangChain matters? Data aware, it is versatile, agentic, it has those models which you can query like student and teacher, modularity, pre-built chains are already existing or you can open source your chain, customizable and persistent. It maintains some stats around chains. What does it mean? If you looked at yesterday, 2 days ago, I looked at yesterday, so I don't know when it came, but ChatGPT 4 have a long retention span of your chains, your commands. And also it can generate up to, like they said, it has a limit right now for 600 characters. It can generate 34 pages for the higher end version of a content in one flow. So not 34 pages, I think 300. I don't know the exact number, but you can literally write with few prompts the whole book if you want it. It has gone that far. So data queries, LangChains are used mostly for that and chat models. You have something called lemma index, which is more deeper indexing. LangChain is querying and fine-tuning. I haven't experimented much with lemma indexing, but it goes beyond. The reach of this is a little bit ahead than, more deeper than, let's put it, than LangChain. I don't have the stats on it, but that's what I know as of today. Model I/O interface for communication and large language model. You can do I/O operations, connect, build applications around it, change, continue that, and then agent format, memory retention, callback. All these three functions are available, or you should use mostly on the LangChain side. This is another exciting thing which we experiment and we are using exponentially in our experiments and our products. Synthetic data. It's so hard to speak to myself for so long, but I'll try. What I was talking, generator and discriminator, anytime we started practicing late 2015 data science, any company I walk in or any situation, the data was the challenge, and what we were calling at that point is computationally statistically generated data. So what we were able to do is, if you give me a data with 3 columns and 3 rows, I know how to combine them nine ways. So I have 9 columns and 9 rows. As simple as that. This does exactly the same thing by taking the original data, fine-tuning some parameters, and generate exponentially high variant of the data, and that is called synthetic data. Very simple. You do it through deep learning, you can do through GAN models, you can do through writing your own algorithms, all true. It has become very, very easy now with platforms coming in. I had some platform, I think I don't have it here. I had some platforms which I listed down and we were able to use them. Its concept is this way. So synthetic original mixed together here with the discriminator. Original is this and synthetic data is this, which is very different from the original one. We use this, we have a platform called Data in Hub, which is a not facial recognition makeup app. And we struggle to get every human being and woman which makeup. So now we use this data to generate a lot of new faces and a lot of new style of makeup. And we are able to successfully generate and train our computer vision model to detect the products which are required to be connected to that look. Simple. GAN models I've been talking in and out. They work both as a generator and discriminator. Both of them compete with each other. So if you have generated 10 numbers, discriminator will say these are not 10 right sequence number. They challenge each other and generator wins. That's the right outcome. This is how internally these systems are working. We took almost semantic data. This is a real thing we did. From there, we were able to create a human being which does not exist. So a typical example, which is negative example, but at the same time, this is the power of these things. I'm going to straight away open for Q&A because the time is limited. We are based in Irvine. Our headquarters for educational is Orange County, Orange. So you guys can come in for 4-hour sessions we hold on weekends with very small amount just to validate that people are true. This is our very diversified team. We have all the world in one room almost. From my left side, this is me in the middle till here. This is the scientific team. MIT, 5 pass, 4, 5 master, 1 PhD, all researchers. On left-hand side, the business and other support. He's also scientist. This is me in the middle, the leading team, our scientific team, the whole high end of education. 5 masters, PhDs, most of them are PhDs. I'm not an MBA. This is one thing I like to talk about. Very amazing journey of 3 people. We had Agar, who was PhD in machine learning. Matthew was an MBA from USC. Kathy, it's not a testimonial, it's a story for people who have grown with us and how they did it. Has a QA background, quality assurance and a little bit software understanding. Igor is the leading stock market predictor in Brazil. You can check him out. Matthew is an investor and an executive. He used this technology and knowledge. And Kathy improved her skills to go to data analytics to data scientist. So there's no limit of learning and no limit of profiles people have transformed through us. On the education side, we offer these programs. Mastering data science with deep learning. This is for if you have experience in doing some kind of data work or a little bit machine learning, possibly master's or PhD into this field. So this is a massive 12-weekend program which take you to the next level in your research and experiment. For the job seekers, this one is the one which is Mastering Applied Data Science. Again, this goes 6 weekend, 12 days full-time, hands-on, where you'll build a resume and skill. We don't offer job support or anything. That's not our goal. We are a real company which does experiments and work. So you'll get massive skills. It includes from a very beginner to a deep learning to a gen model. This is where most of our now focus has gone to. For professionals who are already in the industry and have some kind of a role and they want to enhance their career, this is for you. It goes for 5 days full time. 3 days is revising your concept. Everyone has an awareness or some kind of program they've gone through. And 2 days is full work on our experiments. And same pattern is adopted in the Gen AI professional learning. You do concept building, understanding, everything is hands-on 100% and in person.